All right, folks, so we're here in my lab with my oxygen sensing equipment that I use to measure metabolic rate in organisms. It's a series of pieces of equipment, tubes, and a metabolic chamber. And the basic idea here is that air gets pulled in through a metabolic chamber, this chamber that you could see here. And as the air gets pulled through here, it gets sent through series of pieces of equipment, which I'll explain in 1 second, which are right here. And this gets analyzed, the percentage of oxygen that is in the air sample. So the best way to kind of think about this and view this is starting off with this particular pump right here. This is the air pump, and it's pumping air and pulling air through this valve right here. So we're going to work backwards from this valve because air is kind of going this way through this setup right here. So we'll work backwards and we'll find where the air is coming from. We're going to follow this thick tubing back. Air is getting pulled this direction, right? So it's going from the right of the screen to the left of the screen. It's getting pulled this direction right here. And as it gets pulled that direction, I'm actually measuring the temperature of the air going through this system and also the flow rate of it. That's going to be important in some of the calculations that I'm going to show you later, but the flow rate right now is 0.143. You can see right here, 0.143 liters per minute. So again, it's being pulled from this side of the screen to this side of the screen. So let's follow it back. Here's where the air is going to be being pulled from. Follow this tubing, and we're going to see that it's coming in through this chamber right here, and this is actually the oxygen sensor and oxygen analyzer. So we could see right now it's measuring 20.94% oxygen concentration, which is the concentration of the percentage of oxygen in atmospheric air. Right? So it's being pulled in this direction, right? We'll follow this back. Where is it coming from? Well, our next step right here is this thing called a dryer box, which is on top of the air pump. This takes all the water vapor out of the particular air sample. So it's coming this way, right? So we're coming in this way, going this way. We'll follow this small tubing all the way down. And here you could see the metabolic chamber. So starting on the opposite end of it, here's the free open end of the metabolic chamber right here. This is where the air is actually being pulled from. So all that tubing is generating suction, pulling air from this sample through this airtight chamber, around this tubing, comes up, it gets dried, air is continuing this way, it's going into the chamber, being analyzed, coming down, coming this way, measuring the flow rate as it gets pulled this direction, right? And then tracing it back to our air pump, which is doing all of the work. So that's a basic setup of this. I'm going to zoom out real quick and show you, hopefully, the readout. I don't know how well you can see this, but this is giving us the readout right here. And at 20.947, 20.944, that's that percentage of oxygen that's being measured. Same value that we're seeing on the screen on the other side. This is a demonstration of the equipment associated with what's called a flow-through or open circuit respirometry. And it's called flow-through or open circuit respirometry because air is constantly being pulled through this metabolic chamber. And the idea behind this sealed metabolic chamber is that we know the concentration of oxygen in atmospheric air, 20.94. There's an animal inside of this chamber, which there isn't right now, but if there's an animal inside of this chamber, that animal is using oxygen for its own metabolic rate. So what we can do is we can put an animal in that particular chamber, collect data on the percentage of oxygen that's in that chamber, and compare that to the value taken from an empty chamber, which is going to be 20.94. The difference between those two values is going to be the oxygen consumption, and it's given as a rate, and we know we could calculate the rate because we know how fast air is being pulled through this system. 1 point bumped up a tiny fraction to 0.144 liters per minute. So I'm going to stop this video now, and I'm going to show you another demonstration of what's called closed system respirometry.